Welcome back to the deep dive. We're here to cut through the noise and really get to the heart of what matters in information security. Today, we're tackling a pretty significant new vulnerability. It's something that demands attention, especially if you're working with Python web applications. Okay, so let's dive in. We're looking at CVE-2025-57833. This is a SQL injection vulnerability found in Django's FilteredRelation feature. Our goal isn't just to report what happened, but really understand why it's so critical, particularly for you, our listeners, working with Django.
Absolutely. And what's striking here is the potential scope, the sheer reach. Django powers, well, millions of sites globally. Many of these are high-traffic, business-critical systems. So a SQL injection flaw in a framework that fundamental, that carries significant risk. It's systemic.
That really frames the why it matters. But let's get practical. For folks checking their own systems, where exactly does this vulnerability hide in Django? What's the weak spot?
Okay, so the issue pops up specifically within queryset.annotate and queryset.alias. It happens when developers use Python's dictionary expansion, the Quarg syntax together with filtered relation. The root cause is basically insufficient validation. The keys and values in that dictionary, the ones meant to become column aliases, they aren't checked thoroughly enough.
Ah, okay. So it's not the data values being injected in the typical sense, but the names.
Yeah.
The aliases themselves become the attack vector. That's different.
Exactly. And that's where it gets really interesting and, frankly, dangerous. Carefully crafted input, fed in through that dictionary expansion, can get injected directly into the SQL query that Django generates. And because it's the alias name, it bypasses Django's usual protections, the query parameterization we rely on.
Right, that bypasses part is crucial. The ORM normally handles values safely, but here the alias names become part of the query structure itself, sort of woven into the SQL before data binding even happens.
Precisely. The trust model assumed those alias names were safe, but when user input is used to actually build that dictionary of aliases, that's where the door opens. And while there's no public exploit code just yet, the path to exploitation is, well, pretty clear. It's a serious concern.
Given how widespread Django is, which specific versions should people be worried about right now? And are there common patterns where this filtered relation and quarks combo might show up, things people should look for first?
Good question. So the vulnerable versions are Django 4.2 before 4.2.24, Django 5.1 before 5.1.12, and Django 5.2 before 5.2.6. But crucially, it's not every app on those versions. You need to be using filtered relation with either annotate or alias, and you need to be accepting user input to build that Quarks dictionary for the aliases. It's a specific combination, yeah, but definitely not unheard of, especially in apps doing complex reporting or needing, flexible queries.
Okay, so we know the versions, we know the conditions. The next logical step is mitigation. What's the fix? How quickly can teams lock this down?
Well, the Django team moved fast. They've already released patches. These updates add much stricter validation for those column alias inputs, basically strengthening the guards against bad input during query building. The fix is in Django versions 5.2.6, 5.1.1, and 4.2.24. The advice is simple. Upgrade immediately. Don't wait. This whole thing really underscores a recurring theme, doesn't it? Dynamic features and powerful frameworks. If they touch unvalidated user input, even indirectly, they can create these unexpected attack vectors. It's subtle.
Yeah, it's a critical reminder. Constant vigilance, even with mature, trusted frameworks, you can't assume anything is implicitly safe.
And if we zoom out a bit, think about the bigger picture. This incident really hammers home the challenge of input validation, especially with ORMs, these extraction layers generating SQL dynamically. There's this tension, right, between the power of dynamic queries and the absolute need to keep user input separate from the query structure. It forces developers, hopefully, to look much closer at how user data might influence the SQL, even when it seems like it's only affecting data values.
So, for you listening, beyond just patching the specific issue, here's something to think about. How can your security teams get better at auditing these dynamic query features? Things like dictionary expansion for aliases, not just in Django, but across your entire code base. How do you anticipate and maybe prevent similar issues in other libraries before they even get a CVE?